right, so good morning, everybody. Good afternoon, depending on where you're joining us from around the world. My name is Jesse, and I am here with Exploring by the Seat of Your Pants as your virtual adventure guide for the day. So if you're new to our broadcast, we are all about bringing conservation, adventure, and science into classrooms around the world. And we are so excited because today marks day 4 of our epic Hope for Wildlife series. We have been partnering with amazing scientists around the globe, working to bring back species from the brink, working to really make a positive difference in saving species and habitats across the globe. Now, this is a special partnership in conjunction with the amazing Green Status for Species group at the IUCN and the awesome people at Conservation Optimism, who've just made the most incredible educational resources to go along with all of these broadcasts. Now, we've had the chance to go with the birds. We did penguins and condors. We've talked with sharks, crocodiles, whale sharks yesterday with Gonzo Araju, and today we are continuing our trend in the oceans with Tim Lamont. So he is joining us to talk today about his amazing work listening in on seascapes, understanding the soundscapes of coral reefs, other amazing habitats, and working to use that knowledge to help save these most biodiverse of all ocean ecosystems. So before I turn it over to him really briefly, I forgot one quick housekeeping note. We are going to do a Kahoot today, so if you want to play along with a quick quiz with us between the talk and Q&A, this is our game pin. I'll get this into the chat in just a minute as well, but feel free. We'd love to have you take part in between the broadcast. So Tim, now I've done that, without further ado, I'm going to turn it over to you. Thank you so much for joining us today.
Thanks very much, Jesse. It's a real pleasure to be here. I can't say how excited I am to be sharing what we do and to be talking all things coral reef. I'm really looking forward to hearing everyone's questions, discussing all sorts of weird and wonderful things about the underwater world. And yeah, I can't wait to get started.
Fantastic. Well, do dive in. I know you've got a lot to share with us. And I'll note for our classes too, Tim's got a few interactive bits. So when he asks questions, if you want to be quick on the trigger finger in the chats to let us know what you think, please do feel free to get by your computers to do so. Tim, you're good to go, man. Let's dive in and do this thing.
Great. Thank you. Like I said, it's brilliant to be here, and it's great to be part of this amazing series, this Hope for Wildlife series that has featured so many great speakers, thinking about so many exciting topics from around the world, and thinking about the natural world from a positive point of view, thinking about how we can understand it better, how we can protect our wildlife better, and how we can maintain that for the future of what our natural world is, all the amazing things about our planet and its wildlife. So before we start, I'd like to know where you're all watching from. It would be great to tell us in the live chat, or get your teacher to type in, or whatever it is, and you can tell us where you're coming in from. And while you do that, Jesse can read the answers in a minute, but I'm going to tell you a bit about myself while you're typing in. So I'm a marine biologist. That's the job I do. I live here in the UK, but I work in lots of different places around the world. And one of the best things about my job is getting to spend time underwater and understand and find out more about and spend time with these amazing animals. So in the top left there, that's me with a whale shark, which is the biggest fish in the sea. In the bottom left here, that's me with a sea turtle. They can hold their breath for hours and hours and hours on end. I can only hold my breath for about 2 minutes, so I didn't get to stay there long. On the bottom right, that's me with a dolphin off the coast of Scotland, close to home. And in the top right, that's me very far from home in Australia, getting the attention of quite a big fish called a potato cod. So there's lots of amazing animals underwater that I get to work with as a marine biologist. And I also go to lots of different places. So on the left here, that's diving in the jungle in Mexico, in these underwater caves they have there. In the top there, I'm working in the Arctic Ocean. You can see we're all dressed up very, very warm. And on the bottom, on the opposite end of the scale, working on coral reefs. That's exploring a coral reef in Australia. And on the right, again, trying to work out where to park my boat to find the best coral reef to do our research. And then here's a few more pictures of that. So trying to make our underwater recorders and our equipment work on the left, and then listening in to various animals that you can hear underwater, both in the Arctic and on coral reefs. Jesse, have we got any answers? Where are people watching from?
We got lots of answers. I mean, no one's in quite as romantic and exciting a place as you've shared us in these pictures, but we've got Kansas City, Missouri. We've got all over Ontario, Canada. We've got Topeka, Kansas. We've got Pennsylvania and Collegeville, Missouri. We've got folks from all over North America. And I want to note that in our registrations, we had an entire sophomore class in China register for today's program. They might well be watching it on YouTube as well. And we've got a U.S. Virgin Islands crew that I know has the chance to watch in tomorrow. So a really diverse global audience today, which is really exciting.
That is amazing. Listen to all those places people are coming in from. That's fantastic. Thank you. Now, so you've told me all where you're from. I'd like to know, where do you think there are coral reefs? Because today we're talking specifically about coral reefs. So what countries can you think of that have coral reefs in them? I've told you some of them if you're listening carefully, but there's lots of others. There's many, many countries around the world. Have we got any answers coming in, Jesse?
We'll get them start coming in just a second. While we're waiting for them to pour in, I'll note too, you mentioned the caves in Mexico. I just put the name of those sorts of caves on the broadcast below, so I really encourage you guys to look up the cenotes. They're just incredible, incredible ecosystems. So we've got Australia, Mexico coming in as answers. We've got Australia, Hawaii, so the United States. Great answers, guys. These are fantastic. Any other?
Yeah, really good answers.
In Jordan, so I know the Middle East has coral reefs, and we talked about this the other day. Hawaii, Hawaii and Australia are our two big ones that keep coming up.
Yeah, really good. So some of these pictures I've taken in Australia. So the one on the right is an Australian coral reef. The other two are in a place that hasn't been mentioned yet, which is a place called Indonesia, which is in Asia. So there are coral reefs all the way around the equator, on every continent that crosses the equator. So in the Caribbean, Hawaii is absolutely right. There's coral reefs in Africa, in the Middle East. Someone mentioned Jordan. That's absolutely right. There's coral reefs in Asia, in countries like Indonesia and the Philippines and Malaysia. There's coral reefs in Australia. So really, we see them wherever it's hot by the equator, we'll see coral reefs in the ocean. What is a coral, though? Because these reefs are made up of the sort of most important bedrock animal that makes up these reefs is called a coral, and it's quite a complicated little animal. So I want to share with you a little bit about what a coral is, and you can think of it as being partly an animal, but it's also got elements of it that are like a plant and elements that are like a rock, like a mineral. Okay, so we'll start with the animal. The animal that the coral is closest related to is a jellyfish, except it's not like a jellyfish like you might be thinking of them. It's an upside down jellyfish. Okay, so its body, if you like, is down on the bottom, and its tentacles wave around above it, and it uses its tentacles to catch tiny, tiny little pieces of plankton, tiny microscopic animals, and it catches them and it eats them, just like a jellyfish does. Except it's got an additional superpower that jellyfish don't have, and that is that it has a plant that lives inside it. Okay, it's a bit mind-blowing, but it has this tiny little algae that literally lives inside the coral animal. So it makes it a bit like a combination of an animal and a plant. So it has all these sort of extra superpowers that you get if you have a plant living inside you. So it can photosynthesize. That means it can take the energy from light and use that to grow like plants do. And the algae that live inside the coral also make it really colorful. So while jellyfish often aren't that colorful, corals are some of the most colorful animals underwater. And that's thanks to these algae that live inside them. So the algae come in lots of different colors. You get greens, you get blues, reds, purples, oranges, all sorts of different colors and of the algae. And that's why our corals are so many different colors. And then the final bit of the jigsaw that makes up a coral is the mineral, right? So corals have this additional superpower, as well as having stinging tentacles to catch animals, and as well as having plant cells that can help them photosynthesize. They literally make rocks, okay? So corals make their own reef below them, and they do that by creating calcium carbonate, which is a type of rock. It's the same way that a snail makes its own shell out of calcium carbonate. A coral can make its own skeleton out of calcium carbonate. So in that sense, a coral is an animal that has elements of a plant about it and elements of a mineral or a rock about it. Okay? And one coral is very, very tiny, but actually corals live together in what we call colonies. So you get loads and loads and loads and loads of them. And when they all line up like this, they make a big coral colony, and lots of coral colonies together make a coral reef. So here's a picture of lots of different coral individuals making up a colony. You can see they almost look like flowers, don't they? But those, what you're seeing there is the tentacles waving about in the sea, ready to catch stuff. And below the tentacle is the body and the rock below that. And that orangey yellowy color you're seeing is thanks to the algae living inside. So that's an individual coral. And then there's a coral reef where you've got loads of those individual corals in lots of different shapes, lots of different sizes, lots of different colors, create this amazing ecosystem with all these different types of coral on them. And of course, it's not just coral that you get on a coral reef. Those reefs are also home to turtles and squids and fish and dolphins and whales. In fact, a quarter of all of the world's fish species live on coral reefs. So 25% of the world's fish live on these coral reefs. They really are amazing places to see. So, and as well as looking at coral reefs, you can listen to them as well. So this is what I do in my research. I want to understand more about the sounds of coral reefs, okay? And I'm going to play you some of these funky sounds that all the fish on coral reefs make now. So listen out. First up, you're going to hear the sound of an ambon damselfish. You ready? So that sound, it's almost like a bird, isn't it? That's the sound of that little yellow ambon damselfish. And it's quite different from the sound of another fish, which is called a sergeant major. Listen to this one. So that one, the first fish sounds a bit like a bird. The second fish, I think that sounds a bit like your cat purring, doesn't it? And so the two very different sounds there. This next one is a fish called a reef croaker.
My favorite.
It sounds a bit like a drum, I think. I don't think it sounds like a croak. I think it sounds like a drum. But anyway, it's called a reef croaker. And this last one is a type of clownfish. And listen to the sound the clownfish makes. It's a weird sound, that, isn't it? And it's actually the sound of the clownfish banging its teeth together. That's how it makes sound as it talks to each other. And then some of the sounds, we have no idea what fish make them. And that's part of the fun for me. So we haven't decoded all of these sounds we hear yet. So here's one where we don't know what fish it is. I think that's an amazing sound, isn't it? But yeah, yet to find out what fish exactly is making that noise. And then when you put all of those sounds together, when you swim around the reef and you hear all these different sounds all going on at the same time, it can be quite amazing. There's a real diversity of different sounds going on. It's almost like a big orchestra where all the instruments are playing at the same time. So here's a recording where I've mashed together loads of different sounds to give you an idea of just how many different types of sound there are on a coral reef. There we go. Lots of weird and wonderful noises. So coral reefs, as well as being amazingly colorful places, are amazingly noisy places. Except there's a bit of a problem. A lot of the world's coral reefs today are really threatened. They're in trouble, and they're threatened mainly by these two things that are related to climate change. So because of climate change, we have lots more cyclones, lots more strong cyclones than we usually have. And you can see that picture on the left. They really batter coral reefs, cause lots of damage. And on the right, this thing called coral bleaching, which is where when the temperature warms up, that plant that lives inside the coral, that algae that I talked about, it leaves the coral. It leaves the coral behind. And so then the animal no longer has the plant in it. And that means that the color goes, so the coral turns white, like you can see in the picture, and the coral is no longer able to photosynthesize. It can't make energy from light anymore. And so if it bleaches for too long, it will die. So these are really big problems for coral reefs, and they cause a lot of degradation that is really sad to see. It's a real challenge for us. How are we going to manage and maintain the health of our coral reefs against these threats? And today I'd like to share with you two things that give me real hope that I'm working on as a marine biologist that give me hope for coral reefs and why I think they might have a future and how we can protect and rebuild them. So the first of those is work that's being done in Indonesia. So that's this country in Asia And I'm doing this work with a great scientist in Indonesia called Trias Razak. That's her on the left, looking smart for her work photo. And at the bottom, that's her underwater, counting corals. And we've done some work together where we're looking at across Indonesia at all the different ways that people are trying to rebuild damaged coral reefs, trying to replant coral and bring the reefs back to life. And there's an amazing number. In fact, there are more coral reef restoration projects in Indonesia than there are in any other country on the world. So we've described it as Indonesia leading the way in restoring coral reefs. And so I'm going to show you just one of those programs now. It's a program run by an organization called HARS Sustainable Solutions. And here's what they do. So they make these frames. They call them reef stars. You can see it there. Now, here's two people in Indonesia tying little bits of coral onto this frame, metal frame, called a reef star. And then with loads and loads of those frames, they swim them down to the bottom of the ocean in areas where there used to be coral reefs, but they've been damaged, in areas where they're trying to regrow the coral. And they put a big old network of those frames on the bottom of the sea like that, and they tie them all together. And you can see that's when a sort of set of reef stars has just been installed, just been put out. So you can see lots of the frames all lined up, lots of little bits of coral tied on, ready to grow. And just 3 years later, look at what happens. This is quite amazing. The coral regrows a massive amount. And so you get this massive coral growth. You can see in the top of the picture, the extent of this, how much coral really has regrown. And so such an encouraging thing to see. And this is a project in Indonesia that has really done really well to develop this way of rebuilding coral reefs that have been damaged. Here's some more pictures of the coral growing. You can see some of the frames still in shot, but you can see the rate at which those corals are growing. The ecosystem's coming back. It's all colorful again. And here's a picture or three pictures that show you the process again. So on the left, a reef that's been really damaged, where there's not a lot of coral left at all. In the middle there, people planting out these reef star frames, and on the right, the coral having grown and the ecosystem starting to come back. That's one thing that really gives me hope. And the other is a research project that we're working on where we're starting to think, okay, so people are really good at regrowing the coral, but what about those fishes? Because you can't see any fishes in any of these pictures. So how are we going to get the fishes back as well? So we sat and thought about this, and we went to Australia to do this research, and we thought, okay, how can we bring fish back? What might work? And here's a bit of a clue. So it turns out, as it turns out, there's one of the things that fish are really attracted by and fish really like is the sound of other fish. Okay, and so fish they're all really good at hearing. In fact, every fish we've ever studied has the ability to hear. And when they hear the sounds of other fish and the sounds of a healthy coral reef, they really cue in on that and they swim towards that. So we thought, well, maybe we can use this as a way to bring fish back when we're trying to rebuild coral reefs. So this is me in this picture on the left, and in my hand, that's an underwater loudspeaker. They're the same type of loudspeaker as they use for synchronized swimming. When swimmers, you need to hear the music underwater. And so we took a bunch of those loudspeakers to Australia, and we did this experiment where around this island called Lizard Island, we made a load of identical little patches of habitat. And then we did one of three things. Either we put no loudspeaker there, or we put a dummy loudspeaker, like a fake that wasn't doing anything. It wasn't making any noise. Or we put a loudspeaker playing the sound of a healthy coral reef. And we called that one acoustic enrichment. And we counted how many fish would come to each habitat based on what we were playing. And so, again, here's a picture of us setting up those underwater loudspeakers. And on the left here, there's a graph that I'm going to show you bit by bit, which is going to tell you what the result was. So the graph is going to tell you the average number of fish that turned up to each habitat based on what we played. So first up, when we played no loudspeaker, you can see that red box there. We had about 25 fish on each of our reefs where we had no loudspeaker at all. And when we had a dummy loudspeaker, so that was a loudspeaker that was there, but it wasn't turned on. It wasn't playing any sounds. We also got about 25 fish on each reef. But when we did acoustic enrichment, when we played the sound of a healthy coral reef, we got about 50 or even a little bit more than 50 fish coming onto that habitat. So that's about twice as many fish would decide to come and settle and set up shop on a habitat when we played the sound. So this for me is an example of how, as scientists, we can understand more about the natural world around us. We can understand more about wildlife and what makes wildlife tick. And then when we do, we can use that in ways to help protect it and help rebuild ecosystems. So just very quickly, before we open up for questions, to summarize what we've learned today, what we've discussed. So coral reefs are amazingly colorful and beautiful and diverse places, and there are coral reefs all around the world. Coral reefs are made up of these coral animals, which are an animal that's a bit like a jellyfish, but it has a plant inside it and it makes its own rock. Coral reefs are really damaged and threatened by these climate change related problems, so by these cyclones and bleaching. But there are people all over the world who are trying to find ways of rebuilding reefs. So particularly in Indonesia, they're really good at this, regrowing coral on metal frames. And as well as regrowing coral, we're trying to find ways of bringing back the fish. And you can bring back fish by playing sounds, and you'll attract about twice as many fish when you play the sounds of a healthy reef than if you just don't play any sounds at all. So thanks very much for listening. I'm really looking forward to chatting through this stuff and answering some of your questions. And yeah, thanks for your attention.
Tim, that was spectacular. One of the only people we've ever had on that gave a full summary of their talk at the end, which is a really nice touch. Actually, we're going to try and encourage people to do that more often. Before we dive in with questions, we are going to do our Kahoot, test your understanding. How much were you paying attention? Have a little bit of fun. Now, you don't win anything with our Kahoot, but you do win Tim and I's everlasting respect. So keep that in mind as we start answering these questions. And if you're new to this, the faster you answer, the more points you get. There's already 45 of you in the Kahoot. Come on in and join us. This is going to be about 2 minutes long, and then we are going to take all your questions for Tim. Anything you ever wanted to know about coral or more, you have the opportunity to share those. So with that, I'm going to kick us off. You can join in after you've gotten underway. That's totally fine, but let's do this thing and start off with some fun. All right, here we go. 3, 2, 1. Now, Tim, you can help us out by giving us hints when there's 5 seconds to go in each one of these if you'd like to as well, okay?
Okay, I will do.
All right, coral animals are most related to, we talked about this several times. Is it squid, fish, sea stars that I've weirdly broken up and it's made seas and tars, and jellyfish? Maybe it's not the one that I couldn't even spell properly. That's a hint for you guys.
Another hint is, remember, they can sting, these corals. They have tentacles that sting.
I like it. Great hint. 80 answers in so far. Fantastic. Most of you got this right. A few of you thought fish. No, so they're not related to our fish friends, but jellyfish are our key answer here. Joyful Wolf takes our lead. Way to go. The faster you answer, the more points you get, and we'll head off to question 2. So coral reefs make up this vanishingly small part of the world's ocean, very tiny in the scheme of things compared to other ecosystems. But what percent of fish live in or on them? Is it 2%, 10%, 25%, or 90%? Got our happy clownfish in the anemone here. Very Finding Nemo of us.
Answers racking up. There we go. As a bit of a hint, it's about a quarter.
There you go.
A quarter of fish.
Man, rats, I put 90 already. Almost all you got this. Way to go, guys. So yes, a quarter of all fish species, which is ridiculously outsized. It's like tropical rainforests have an outsized proportion of biodiversity that live in them on land, and coral reefs are sort of the jungles of the sea. Joyful Wolf takes our lead. Bright Bunny is in second, very close behind as we go to question 3. Get your questions ready too. Think about what you want to ask Tim in a minute. So when coral algae depart, when they leave, and you end up with that big white reef like we have in this very scary picture, it's a process called skeletonizing, bleaching, decoloring, or just dying. That's it for the reef entirely. What do we think? 80. Oh, there's more of you now. There's over 100 of you. Holy, this is our biggest Kahoot of the entire series so far. Way to go, guys. 2 more seconds, and our answer is bleaching. Almost everyone. 104 of you got that right.
Good work, everybody.
Oh, Bright Bunny takes our lead in a shocking switch. Okay. Our final question, and then we're going to Mr. Tomlinson's class first for questions. What happened when scientists played the sound of healthy reefs on degraded ones? Nothing? No fish cared whatsoever? It discouraged the fish? It was too noisy. There was no room for them to come in anyway, or it doubled the rate that fish returned. We covered this numerous times. I hope you all get it.
There we go. Answer up past 100.
1. Ah, so good. Way to go, Kahoot friends today. It doubled the rate. So yes, fish came back in droves because just like if you went to an apartment building and it was derelict and there was no one living in it, there was no sounds, you might not want to move in, but if there's tons of things happening and a potluck happening, you might think, oh, this is a nice place to live. Same with our fish. So Joyful Wolf in 3rd, Bright Bunny in 2nd. So a spoiler for the winner. Coming out of nowhere is Soaring Ferret. Way to go, guys. If you are any of these folks, let us know who you are in the chat. Thanks for playing along. And we're going to head to Pennsylvania for Mr. Thompson's class for our first question. Unmute your mic, guys, and you're good to go. Come on in. Hey.
What is the most interesting thing you've seen in a coral reef?
Ooh.
Oh, that's a great question. Really, really good question. What's the most interesting thing I've seen in a coral reef? Am I still there, Jesse? My screen's going to work.
You're here. No, you're good. You're all set. I just put you full screen so people could see you as you answer.
Brilliant. Okay. So the best thing I've seen on a coral reef, the most interesting thing is a fish that's called a slingjaw wrasse. Okay. And it's a funny name, but it's called a slingjaw wrasse because it can literally sling its jaw forward. And so it's got this mouth that its mouth can turn into a big tube that's a third of the length of its body. Okay, so imagine if you saw a bit of food in front of you and you wanted to try and catch it, you could literally shoot your entire mouth in front of you to a distance of about 50 centimeters. That's about a third of the length of your body. And so I've seen these fish do this, and it's absolutely amazing. They're swimming along and they look like a normal fish, and then suddenly the mouth comes out of nowhere. It shoots forward. It's like a third of the length more of the fish. It's an amazing thing.
So in our history of broadcast, we've never had someone mention this fish, and they are extraordinary, and everybody should look them up when they're done this program. I'll try and find a picture actually that I can bring up on screen for people in a minute so they can see it, but it's a really charismatic and special animal. Kansas City Academy, if you guys want to unmute your mic and come on up, you should be good to go for a question if you got your audio going. Hey, guys.
Hi. Can you hear us?
Yeah.
Okay. My question for you guys is, what does coral taste like?
Ooh, Tim, do we know?
What does coral taste like? I've never tasted any myself, but there's lots of fish that eat it. So presumably coral tastes quite good if you're a butterfly fish. Okay, so that's the type of fish that really likes eating coral.
One of my favorite things about things eating coral is the idea that all these tropical sand beaches, these beautiful things that people lounge in all day long, are to a significant degree in some places made up of poo of fish that have eaten coral reefs and just excreted them. So next time you're like lounging and your feet are luxuriating in that sand, just think that some parrotfish ate some coral reef just offshore, and that's the result of that is what you're standing in. 5 6s in Brockman. Come on in, guys. If you're up to the thing, your mic's unmuted. Hey, welcome in, guys. Hi, does anyone have any questions for Kim?
Do we have any? One of the students wanted to know what your favorite fish was.
Ooh, my favorite fish. So we talked a bit about the slingjaw wrasse before, so that's definitely one of them. I like some of the ones that make funny noises too. And what other fish are cool? I like seeing sharks on the reef. That's always nice. And yeah, so one of my favorite things is actually just how many different types of fish there are. Right, that it's like you can look in any angle, any direction on a coral reef, and there'll be a different shape, a different color, a different size of fish. They're just all so crazy different from each other.
Yeah, outstanding. Grade 6s, if you guys want to unmute your mic and come on in, you're good to go. Let's see. Hello, guys. Yes, you. Unmute. Come chat with us.
Have you ever seen a coral that moved by itself?
Ooh, a coral that moved by itself. They're pretty stationary. They create that rock skeleton and then they fix themselves to the seabed. But what they do is when they reproduce, they spit their eggs and sperm out into the sea, and then those little babies in that early stage of their life can then swim around into different places and land somewhere else. So they don't move as adults, but when they reproduce, it's in a process called spawning. Their little babies can move quite long distances in some cases, and that's how you get coral reefs growing.
I will say too for our students that I'm a biologist by background. I grew up with nature documentaries, and the first time I ever saw coral spawning, I was probably about 21 on a nature documentary. I've never seen it live. It is my favorite thing in all of nature. It's like fireworks underwater. In some reefs, you have like thousands and thousands of coral all release their eggs, which look like little colored balls, red, yellow, purple, the most amazing colors, and it fills the sea around them. It's just a magical, magical thing to check out. So I really encourage our classes to go see that in a second. And while I'm waiting to bring up some YouTube questions, I wanted to share this with you because it's so over the top, our sling jaw wrasse. So you can see this giant tube mouth now, and then some of the pictures of the normal fish to the side of it. But look at that mouth. It's just spectacular. What a weird animal. Oh, very good. All right, we're going to take a few from YouTube. We've got some really interactive YouTube classes, and then we'll come back for one more live round. So Ms. Rula wants to know, how many of the metal reef starters are there in one area? When you put them on the ground, are there tons? Do you put 100? Do you put 5? What's the benchmark?
That's a great question, Rula. It really depends on the project, and there's lots of these reef star projects around the world. So in some of them, they're building thousands of square meters of coral reef. As far as the eye can see, it takes a long time to swim over all this new reef they've built. And in those cases, they'll be planting thousands of these metal frames all side by side. In other cases, there's smaller projects, and so people are just building little patches of reefs or repairing a small amount of damage, and then they might just put down 10 or 20 frames. So really, there's projects of all sorts of different sizes.
Yep, fantastic question, guys. All right, we're going to take another one from Mr. Rand's class. How long does it take coral to grow back after damage? So let's bring that up on the screen too.
That is a really, really good question. That's a really important question, actually. And the answer is that it depends what type of coral. So you might remember me saying that there's lots of different types of coral, and the fastest growing ones will grow back in a year or two, sometimes even. They grow really quite quickly, but the slow growing ones will take 10, 20, 50, even sometimes 100 years to regrow. So there's a real range, and that's one of the reasons why it's really important when we're rebuilding reefs to think carefully about what types of coral we're planting, to make sure we're planting a balance of all the different types that there are. And it's also a really important reason why it's better to protect reefs in the first place than it is to just assume that it's okay if we damage them because we can rebuild them. Because in lots of cases, it's going to take a long, long time for some of these corals to regrow. So definitely better to protect them in the first place if we can than to rebuild them.
I'm really glad we got that message in. So this is something that we hear a lot in our conservation themed programs. Oh, we can just clean plastic out of the ocean. Oh, if we make something extinct, we can bring it back from the dead. And I mean, in some cases, some of these solutions are technically possible, but no matter what, they represent so much more investment, time, challenge than just doing the proactive measures to help protect these ecosystems in the first place. And I think that's one of our abiding messages and Hope for Wildlife that we want to leave you with, is that if you protect things while they're abundant, you have that abundance for centuries or millennia to come. If you get down to something very, very small, it's very, very challenging to bring something back from the brink. So yeah. Tim.
Absolutely. It's a bit like your own body in a way, isn't it? Like, if you fall over and you break your leg, then yeah, it will probably heal, but it's going to take a lot of time. It's going to take a lot of effort on the part of you and your doctors, and it's going to be a bit of a painful process. And so better to just not break it in the first place if you can.
I like that analogy. Very good. I'm going to share a quick picture of coral spawning for everyone so you can see what I'm talking about here. So no individual picture does this justice, but this is a sense from Google of just the beautiful colors and the amount of these eggs that go up. And it's just a magnificent thing to witness. So I hope everyone gets the chance to look up more of that when they're done. We're going to take 2 more from YouTube, and then I'm going back to Mr. Tomlinson's class. So Miss Zykowski wants to know, how many reefs have you explored or studied on? The jealousy question.
That's a great question. So I've done most of my work. I've done in Australia and in Indonesia on maybe 5 or 10 different reefs. So I spend most of my time there because I know those reefs really well. So when I go there, I'm able to spot any changes that have happened. I'm able to know exactly where to go to deploy my equipment. I know all the sort of types of fish that live there, and that really gives me an advantage. But I also work with lots of other scientists around the world. So science is a really collaborative game. It's like people work in big teams of scientists, and so often I've worked on reefs that I've never actually been to myself because someone else has been to the reef, taken some measurements or some pictures or some recordings, and then they've sent that to me, on email or on WhatsApp or whatever, and said, hey, what do you think of this? And then I've done some work to analyze that data. So in a sense, I've done research on reefs I've never even been to.
I always love this, and this has been, again, an abiding theme with all our scientists in Hope for Wildlife, is the idea that if you end up in science, if you choose something like this, especially conservation biology seems to be very much like this, it's such a collaborative process. You get to work with amazing people around the globe. You quite often get to go to amazing places like you showcased at the beginning. I mean, what a great job to get to do something that you love with a positive impact and get to go to extraordinary places and work with amazing people. There's very few roles on this planet that allow people to do things like that. So I'm really glad we got that question. Miss Leffert has a very good technical question. Where do you get the power to power the speakers?
That's a really good question. And so far, the way we've done it is I've got power out of motorcycle batteries. So motorcycles run on batteries, which are, about, I don't know, a bit smaller than a shoebox. And we get those batteries and we put them in these waterproof barrels. And then I float those waterproof barrels using rubber rings. And the battery floats around in this rubbering barrel type thing above the reef. And then the speaker is underneath it. And that's how we've done it. But we're playing with other solutions as well. So there's groups in Australia who are now trying to develop this further, and they're looking at getting solar panels installed on the barrels so that you don't have to change the batteries ever because the sun powers the speaker and all that sort of thing. But that's where we're up to so far.
I like the jerry-rigged science, though. This is something that you find in a lot of countries that aren't Canada, the United States, the UK, around the world. Is like, what do we have on hand? What can we throw into making this work? And it's amazing the solutions that people come up with. So I'm really glad we got that question. Mr. Tomlinson's class, come on back in, guys, and unmute your mic. You're good to go. Hey. Yeah.
I'm Ryan, and I'm wondering what is your favorite kind of coral?
Ooh. Favorite kind.
Yeah, really good question. My favorite kind is probably a kind of coral called Acropora. So all of the corals have Latin names. And so there's Acropora, and there's Pocillopora, and there's Pavona, and there's Porites. They all have these sort of Latin sounding names. But I like one called Acropora because it grows very quickly. It's very beautiful to look at. It has all these branches. It looks like a branching tree when it grows. And it comes in lots of different colors as well. So you get Acroporas that are green and that are purple and that are almost like reddy sort of colors. And yeah, I think it's a beautiful coral.
They sure are. I was looking them up to get that spelling and make sure I had it right. They're just a gorgeous, gorgeous coral. So people can check that out when they're done the broadcast too. Kansas City Academy, unmute your mic. Come on back in, guys, and join us for a question. Hey.
My question was, what is the biggest coral reef that you've visited?
Nice.
So the biggest coral reef that I've visited is the biggest coral reef in the world, which is the Great Barrier Reef, which is off the coast of Australia. And so it's an entire coral reef that is probably about the size of Italy. And so it's, about, thousands and thousands of kilometers of coral. And so it's one of the things I think is amazing about these reefs is that each individual coral animal is so small you'd need a microscope to see it. And then when you put them together, they make these coral colonies. And when you put these coral colonies together, they make these entire reefs. And some of those reefs are the biggest living structures on the planet. So it's really just an amazing thing to see.
Of all the analogies of the Great Barrier Reef size, I've never heard Italy, but I love it as an answer. It's fantastic. 5-6 Brockman class, if you guys want to come in, we'll head to our other grade 6s for another live question after that, and then I'll make sure you guys have all the resources to keep the learning going because time flies and you're having fun, folks. We're almost done our broadcast. Brockman, come on in, guys.
Go ahead. How many of the reefs have been damaged by the bleaching or the cyclones?
Great question.
Yeah, that's a really good question. The damage is quite variable. So at times there's a lot of damage. Like if there's a really bad bleaching season, then loads of the reefs will be damaged. But then at other times there's some recovery as well. And so then, it's like a constantly moving number that. And there are some predictions going forward that if we don't sort out climate change and we don't get better at rebuilding them, that up to like 90 or more than 90% of these reefs could be really heavily damaged by the year 2050. But I'm hopeful that we will be able to stabilize the climate before that. And I'm also hopeful that we will learn to be able to protect and rebuild reefs better. And that essentially is why people like me do our jobs, to try and bring that number down, to try and fight for the coral reefs that we still have and try and rebuild the ones that have been damaged.
Well, again, the whole essence of your talk is the hope for coral reefs because of the work that you and amazing colleagues are doing around the globe. And so it's really nice to feature those stories because, again, not just kids these days, we hear all the time on the news, oh, this new dire prediction, oh, this new dire prediction. And so it's really important to highlight that there are tons of legions of passionate, dedicated people whose whole lives are working to make sure that we have this future of abundance where there's as many fish and coral reefs as there are in this image around us here. There are really some extraordinary places on this planet, and it really behooves us all to work to protect them collectively. So great question, guys. We're going to take one more from our grade 6 class. I will note before I go to them too that we are going to have a Padlet. So if you have additional questions that you'd like to share with Tim after the broadcast is done, you can head to this link below. I'll send that to all our registered classes. Share your queries there and inundate him with even more coral know-how and queries. Grade 6 group, unmute your mic for fun. Yes, you guys, come on in. Unmute for one final question. Welcome in, guys.
How deep have you gone to see fish?
Yes.
How deep have I gone? That's a good question. So I've dived down to about 40 or 50 meters. So that's about 150 feet. So quite a long way down under the surface of the ocean. You definitely need a scuba tank for that. It's very difficult to swim that far down. And some other people have gone even deeper than that. And then when it's deeper than that, even people have sent submarines down to see fish. And so the ocean is far deeper at its deepest point than Mount Everest is tall. And so there's a massive amount of ocean to explore. And yeah, you're right. That going deep, we discover stuff that's different from in the shallows.
If students are interested, we had Julia Spade on earlier this week. She went down in submersibles to find creatures that were much deeper down than people can typically dive. And then we had a deep sea program, not in this series, talking about the Mariana Trench, really, really deep ocean places with some of the really fantastic, unique wildlife that's down there. So keep the learning going with all those things. I really encourage our classes more than you know. Tim, we could talk all day about coral, but I know we need to wrap up our broadcast soon with folks getting ready to go. So I want to share a lot of resources to keep the learning going. Number one, again, share more questions on the Padlet. Head to the virtual whiteboard now, inundate them. I'll help answer those too, so we don't make Tim have to miss any trips to Indonesia to help protect coral reefs. You can also check out the Conservation Optimism Kids Corner. They did an interview with Tim, some beautiful infographics, resource sheets, and more to keep the learning going. And where is this that I wanted to bring up? Oh, yes, our art contest. So for people that might not have seen our James Webb Space Telescope art contest, we've got another one set to go with Tim's team at the University of Lancaster, with OceanWise, another one of our big partners. And so I'll make sure all our registered classes have the details of that art contest, how you can draw what you'd like to see on a coral reef out a submersible window, and get involved and just have a good time. We've got some great prizes for everybody. So if you want to tune in and join in with that, we'd love to have you take part. Tim, is there any final message you want to share with us about coral reefs, the amazing work that you do before we bring in our classes to say a big thank you and farewell?
I just want to say thanks to everybody for coming. It's so amazingly encouraging to hear some great questions, to see how many people are excited and interested by this stuff. And I think that gives me more hope than anything else that together we can all work out solutions for our coral reefs and for all the wildlife on this planet that will be able to create a future that is more full of hope than the one we inherited.
Tim, there is no better final message than that. And so I know you've joined us before, but we'll do it again with you. We'll bring in all our classes to say a big thank you and farewell. Mr. Tomlinson's class, Kansas City Academy, Brockman, grade 6s. You guys want to all unmute your mics and join me in saying a big thank you and farewell. Join in at home too, why not? Thank you guys so much for joining us for our broadcast. Bye, everybody.